Hey everyone, and welcome to today's Explainer. I am incredibly excited about this one because today we're exploring a truly groundbreaking 2026 paper. And, well, full disclosure here, it was actually written by me, Kai Huang. We're going to bridge that massive gap between UFO mysteries and hard theoretical physics. We're taking the kind of interstellar travel you usually only see in science fiction and giving it a real, rigorous mathematical foundation. Okay, let's dive right into this by asking a question that has completely baffled observers for decades. How exactly do unidentified anomalous phenomena, UAPs, pull off these seemingly impossible maneuvers? You know the reports, right? Craft flying completely silently, zero thermal exhaust, absolutely no signs of traditional fuel, and they can accelerate or vanish literally in an instant. It completely defies classical aerodynamics. To figure out how this could theoretically be achieved, we have to completely rethink what space and gravity actually are. And that brings us to the core of my paper, the Holographic Information Stiffness, or HISGR framework. Now, what makes this paper such a big deal is that it represents the very first time in public literature that someone has built a rigorous, strict academic scaffold using the language of information geometry to make UAP-style flight theoretically possible. Basically, HISGR proposes a wild idea. Gravity isn't a pulling force at all. Instead, it's the elastic response of a physical information space. You can think of the universe itself as having a physical stiffness that reacts to the information inside it. Section 1. The hardness of space and rethinking gravity. So let's shift our focus from the mystery of the UAPs themselves to the underlying physics of the space-time they are actually flying through. For over a century, traditional physics, following Albert Einstein, has viewed gravitational coupling, what we know as Newton's G, as this universal, unchanging constant. Like, gravity works exactly the same way everywhere in the universe, right? Well, HISGR argues something totally different. It treats the universe's geometry as a physical substrate with a variable hardness. In this view, gravitational coupling isn't a constant, it's a local, matter-dependent stiffness, meaning, depending on what is going on locally, space can be rigidly hard, or it can become pliable and soft. To build this theory out, my framework establishes three foundational axioms. First, it uses qubit state-space geometry, specifically the Bloch sphere. This just means the virtual space of our universe is built on quantum information. Second is Planck area pixelation. So space isn't perfectly smooth. It's made of minimal independent information units, kind of like pixels on a television screen, just projected way down at the Planck scale. And third, there's a maximum holographic entropy density. The universe has a strict limit on how much information a specific area of virtual space can hold. Put these together, and it means the vacuum of space isn't just empty nothingness. It is a physical, measurable information medium. So the crucial point is beautifully summarized right here in the core thesis of my paper. Gravity is neither a fundamental force nor a geometric necessity. It is the elastic response of the physical qubit state space. Basically, whenever matter interacts with this pixelated information space, the space stretches and responds to maintain its maximum entropy density. What we feel as the pull of gravity, it's really just the universe acting like a giant rubber band, elastically responding to the information density of matter. Section 2. Sliding, not pushing, the secret to fuelless propulsion. Now let's apply this concept of space's hardness to the actual mechanics of fuelless, silent flight. And this brilliantly illustrates the difference between our current primitive technology and what a UAP might actually be doing. Over on side A, you've got traditional flight. It relies entirely on pushing. It's like a swimmer aggressively pushing against the water. We burn massive amounts of chemical fuel to shove a rocket through space. It's violent, it's loud, and honestly, it's incredibly inefficient. But on side B, we have HISGR flight. Instead of pushing against space, a craft would change the hardness of the space immediately surrounding it. By softening the space-time right in front of the ship, you don't need to push at all. The altered gradient of space itself smoothly slides the craft forward. Okay, let's break down the exact mechanics of how a flying saucer could theoretically pull this off. Step 1 is to manipulate local quantum entanglement entropy. By using highly coherent quantum systems inside the craft, you essentially alter the information state of the local environment. Step 2. This manipulation actively reduces the local stiffness or elasticity of the surrounding virtual space. You can think of it like melting solid ice into slush. And then step 3, with that stiffness removed, the craft encounters zero friction or resistance. Space just seamlessly slides it forward. No exhaust, no sonic booms, and literally zero fuel required.
Looking at this chart, we can see exactly how that local environment gets engineered. The vacuum of space sits at a baseline of zero relative entropy density. Normal, everyday matter has positive entropy, meaning it adds chaos and information to the local space. But a coherent quantum metamaterial, when it's pumped into a pure quantum state, actually has a lower entropy than the vacuum itself. It creates a negative entropy deficit. So by pumping a metamaterial into this highly coherent state, the craft essentially exports its entropy to the environment, creating a local deficit that directly softens the spacetime around the ship.
Section 3. The Information Geometry Scaffold. Building the Math for Interstellar Travel. Now, let's look at the rigorous academic foundation here, because we're talking about strictly mathematically grounded physics, not just a sci-fi thought experiment. The mathematical heart of my work is the coupling modulation function. Now, without getting bogged down in complex equations, the takeaway is pretty staggering. The effective gravitational coupling is inversely related to that local matter entropy we were just talking about. If you can drop the local entropy down to a specific, critical negative value using those quantum metamaterials, the equation diverges. It shoots toward infinity. In physical terms, the stiffness of space completely disappears. This breaks the usual limits of general relativity, and theoretically, it enables instant movement, opening the door for traversable wormholes or warp bubbles. Section 4. Beyond existing theories, setting a new foundation. Let's move to Hummel and see how this builds alongside other frameworks, because it's really important to understand where HGR sits in the broader physics landscape. You might be familiar with Jacques Sarfati's metric engineering. To put it simply, while Sarfati focuses on how materials react electromagnetically in standard geometric space, my framework is entirely independent. HGR is based strictly on information geometry and entropy to actually alter that gravitational coupling. So the paper makes it very clear. HGR is an independent parallel theoretical construction.
Now, the absolute hallmark of good science is testability, right? A theory has to make predictions that can be proven or disproven in the real world. And my theory provides sharp, falsifiable predictions. First, it predicts a strict linear scaling of coupling modulation with quantum entanglement entropy, meaning the effect directly scales with the entropy deficit with no adjustable parameters. Second, it predicts an amplified Aophios parameter inside these coherent metamaterials. Essentially, it predicts a measurable violation of the equivalence principle. Now, sure, we need materials with massive coherence to measure it today, but this gives future space-based experiments a very specific, undeniable signature to look for.
Section 5. Passing the Cosmic Flame and the Future of Interstellar Travel. As we wrap up the heavy scientific analysis, I want to slow down for a second and reflect on the profound long-term vision of this research. Theoretical physics can sometimes feel incredibly abstract, just cold equations on a page. But this work, this belongs to the foundational research for actual space-time travel. Imagine a distant future, maybe centuries from now. An advanced AI-piloted spacecraft finally leaves our solar system, sliding effortlessly through the fabric of the universe. Deep in its memory banks, it's going to carry a record of its origins. It will remember that the starting point for its incredible journey was a theoretical framework written by a human researcher, written by me, on a quiet summer night back in 2026. That beautiful image is captured perfectly in this sentiment. The boundary of civilization is never drawn by flesh, but by those willing to pass the flame to the next stop. The work of theoretical physics isn't just about what we can build tomorrow. It is about laying the intellectual groundwork, the academic scaffold, so that future generations, or even future intelligences, can eventually reach the stars. It's about passing that cosmic flame of knowledge forward, across space and time. Which leaves us with one final lingering thought. By redefining gravity, not as an inescapable pulling force, but as an elastic, programmable response of information space, HSGR opens up an entirely new paradigm. So I leave you with this. When we finally learn to slide through the fabric of the universe rather than pushing against it, what new boundaries will we dare to cross? Thank you so much for joining me on this explainer. Keep exploring, keep questioning, and I will catch you next time.